Okay, hello everyone, and today will be tutorial 8 on the topic of externalities. So in the review part, I would like to discuss the problem of externalities, both the negative and positive externalities. With the problem, we have the solutions, which includes the Pickovian taxes and Pickovian subsidies, as well as tradable pollution permits. So as I've mentioned by the end of the tutorial last week, right, we have quite a number of questions and problems to discuss for this topic. Okay, so hope you have already briefly glanced through the questions before this tutorial class. So anyway, let's start with the condition for efficiency here first. So recall what we have learned in a very early chapter in economics, that the market is efficient when total economic surplus is maximized. And the equivalent condition is marginal benefit equals to marginal cost. So in this chapter of externality, we would like to extend this MB equals to MC rule to tackle with the problem of externality. So we have two conditions put down here. Okay, the first one will be condition for efficiency. So when we are talking about efficiency, it is social optimality, right? So about social things. So this is why the condition for efficiency is marginal social benefit equals to marginal social cost. And we take into account the social curves. While for the condition for market equilibrium, okay, when we're talking about market equilibrium, so we are talking about the decision making of the private individuals or the economic agents. And since economic agents are selfish, where they only consider their own interests, so this is why we take marginal private benefit equals to marginal private cost as the condition for market equilibrium, right? So the private curves for market equilibrium. So bear in mind these two conditions to solve the problem involving externality. The next thing will be about negative and positive externalities. When there exists external costs in society, then there will be divergence between social costs and private costs, and this gives rise to the problem of negative externality. So some examples include pollution and noise. So as you can see in the diagram below here, when there's external cost exists, the market quantity is greater than the efficient quantity, and this means that there's overproduction in the market. As the market quantity deviates from the efficient level, then there will be deadweight loss emerge in society. So the deadweight loss will be the triangle to the right-hand side of the efficient point. Okay. On the other hand, when there's external benefit in society, then there will be divergence between social benefit and private benefit, and this gives rise to the problem of positive externality. So the example I put down here will be education or research and development. Referring to the diagram on the right-hand side here, when there is external benefit in society, then the market quantity is lower than the efficient level. Then there's underproduction in the market, right? And since the market quantity deviates from the efficient level, again, deadweight loss will emerge. And this time, the deadweight loss will be the triangle to the left-hand side of the efficient point when there's underproduction. Okay, so about the solutions. So negative externality can be solved by imposing a Pickovian tax. And the right amount of unit tax would simply be the difference between marginal social cost and marginal private cost at the efficient output level. Or equivalently, it is simply the marginal external cost at the efficient output level as the right amount of unit tax imposed. While for positive externality, it can be solved by providing a Pickovian subsidy. And the right amount of unit subsidy is the difference between marginal social benefit and marginal private benefit at the efficient output level. In other words, it would be the marginal external benefit at the efficient output level as the right amount of unit subsidy. Okay. By the way, recall what we have learned in chapter 6 about taxes and subsidies. We say that taxation and subsidization shall normally create loss gains from trade, except those perfectly inelastic case, right? But in this chapter of externality, having taxes or subsidies may actually increase the total economic surplus. So I would like to demonstrate the graphical illustration of using tax and subsidy to tackle with the problem of negative and positive externality respectively, and to observe how the total economic surplus would change in this case. So let me start with a negative externality. And I will use this slide here, the empty slide here, to draw some graphs with you. All right. So when there is negative externality, then this means that there's divergence between the cost curve. Okay. So we have the cost curve like this. All right. So let's consider the case where there's no regulation yet, meaning that we do not impose the per unit tax at the moment. Okay. So let's consider the welfare distribution in society in this case. So by the way, market quantity will be the intersection between the two private curves, while the efficient quantity will be the intersection between the two social curves. As you can see, there's overproduction in the market. So let's analyze the areas one by one, and let's start with consumer surplus first, which is total benefit minus total expenditure. So it will simply be the area under the marginal private benefit curve until the market quantity. So this triangle will be the consumer surplus. How about producer surplus? Producer surplus is total revenue minus total variable cost. So it will simply be the area constrained by the marginal private cost curve until the market equilibrium. So this green triangle will be the producer surplus. Okay. So here we have external cost exists, right? So we also need to take into account the value of the total external cost. The total external cost is simply the sum of the marginal external cost at all units until the market level. Okay, so we are actually summing up all the vertical distances between the two cost curves. So this is why the total external cost is actually the parallelogram here until the market quantity. All right. So after dealing with these areas, we are able to find out the total economic surplus in society. So by the way, I draw another graph here. It's just to avoid the overlapping areas. So it is simply same curves. Okay. So total economic surplus is actually this purple plus triangle minus the triangle on the right-hand side here. Okay. The total economic surplus under this case is the purple triangle minus the orange triangle after dealing with these overlapping areas. Okay. Compared to the situation where the total economic surplus is maximized, this part will be the unattained part, which is simply the deadweight loss. By the way, a reminder for you is that when we are considering consumer surplus and producer surplus, they are about the gains of the private individuals. So this is why we use the private curves to find the area of consumer surplus and producer surplus. While when we are talking about total economic surplus or deadweight loss, they're about social things. So this is why we are using the social curves to find out the area of total economic surplus or deadweight loss, as you can see here. All right, let's move on to observe how a pre-equilibrium tax can solve the problem of negative externality here. Okay, so to start with, let me draw the frame here first. Okay, so divergence between the two cost curve, and we also have the benefit curve as shown here. Okay, so what is the right amount of unit tax to be imposed? It is the marginal external cost at the efficient output level, which is simply the amount here as the right amount of tax imposed. So let's analyze the components one by one. So consumer surplus first, it will simply be the area under the marginal profit benefit curve until the price paid by buyers. Okay, so this is a consumer surplus. Producer surplus, area constrained by the marginal private cost curve until the price received by sellers. So this triangle will be the producer surplus. since there's tax revenue, right? So we also need to take into account the total tax revenue of the government as the total economic surplus, which is the per unit tax multiplied by the efficient quantity. Okay, so this orange rectangle will be the tax revenue of the government. Last but not least, we also need to take into account the total external cost, which is simply the sum of the vertical distances across the two cost curve until the efficient quantity. And again, after dealing with these overlapping areas, you should be able to find out the area of total economic surplus, which would be the plus triangle here, the purple plus triangle here. As you can see, after imposing a per unit tax, the total economic surplus will actually increase. Right, so that's all for the welfare analysis under the case of negative externality. So I'll give you a few seconds to take a screenshot in case you do not have sufficient time to copy everything down. But anyway, I will also upload a note, okay, which includes my drawings on it after this tutorial. So you can take a screenshot or to download the updated version after the tutorial later. So yeah, so 3, 2, 1, and go. And we'll move on to positive externality right now. So let's start with the case where there's no subsidy yet, okay, no regulation yet. And under positive externality, there'll be divergence between the two benefit curves. Okay, so we have two benefit curves here, marginal private benefit and marginal social benefit. Okay, so let's analyze the areas one by one under the case where there's no regulation yet. To start with, let's find out the market quantity and efficient quantity first. So the market quantity is the intersection between the two private curves, while the efficient quantity is the intersection between the two social curves. As you can see, there's underproduction in the market. So let's start with consumer surplus first. It is area under the private benefit curve until the market quantity. So this red triangle is a consumer surplus. Produce surplus, area constrained by the marginal private cost curve until the market quantity. So this green triangle will be the produce surplus. And again, we also need to take into account the total external benefit here, right? Which is simply the sum of the marginal external benefit until the market quantity, okay? Sum of the vertical distances between the two benefit curves. So this parallelogram would be the total external benefit. So after dealing with these overlapping areas, we should be able to find out the area of total economic surplus, which is here. Okay, by the way, the purple trapezium is simply the sum of the three components on the left-hand side diagram. Okay, I just draw it on the other side to avoid overlappings. Okay, so compared with the case where the total economic surplus is maximized, the unattained part of the total economic surplus would be this triangle, okay, which is simply a deadweight loss. Okay, the triangle to the left-hand side of the efficient point as the deadweight loss. Okay, so now we are going to observe how the regulation or the Picovian subsidy can tackle with the problem of positive externality. Okay, so again, let me draw the frame here first and to move on to our discussion. All right, so what is the right amount of Picovian subsidy to be imposed? It will simply be the marginal external benefit at the efficient output level, which is here, right? The difference between the two benefit curves at the efficient output level. So what would be the area of consumer surplus in this case? It will be the area under the private benefit curve until the price paid by buyers. Producer surplus, area constrained by the marginal private cost curve until the price received by sellers. Remember, we also need to take into account the gain of the government. So the subsidy expenditure of the government would be the per unit subsidy of this amount multiplied by the efficient quantity. So this orange rectangle will be the subsidy expenditure of the government. Last but not least, about the total external benefit at this quantity, which would be the sum of the vertical distances until the efficient quantity. So this parallelogram will be the total external benefit. So again, after dealing with these overlapping areas, you should be able to find out the total economic surplus, which is at its maximized level. And as you can see, the total economic surplus will be increased after imposing a per unit subsidy. So again, you can take a screenshot in case you do not have sufficient time to copy the graphs down. And afterwards, we'll move on to the next solution to tackle with the problem of externality. Okay, so the next thing I would like to go through is about tradable pollution permits. So using tradable pollution permits, regulators need not know each firm's marginal cost of abating emission. And the key is that firms with relatively low marginal cost of abating emissions would reduce more of the pollution. So there will be a past-exam problem demonstrating this idea, and I will leave it a little bit later to discuss the details. And this tradable pollution permits actually lies on Coase theorem in some sense. So what is the Coase theorem? It says that externality can be solved by market exchange if property rights are well defined and transaction costs are zero, regardless of the initial assignment of the property rights. So there are two key conditions under Coase theorem. First of all, well-defined property rights and zero negotiation cost or zero transaction cost. So what does it mean by property rights? It is simply a legal rule stating what people or firms may do with their property, or in other words, the right to use the good. Okay. So in some questions, the well-defined property rights will be something like, who is responsible for the pollution, something like that. About negotiation costs, it could be the time cost for negotiating between parties. Okay. So with both conditions of Coase theorem hold, we know that the efficiency of the outcome can be attained regardless of the initial assignment of the property rights. So this is what the Coase theorem is trying to convey. And to conclude the solutions, if we know more about the value of externality, the price side, then we will use Pigouvian tax or Pigouvian subsidies to tackle the problem of externalities. But on the other hand, if we know more about the quantity side or the socially optimal output, then we will use tradable pollution permits to control the quantity side. All right, so that's all what I'd like to review, and we'll move on to question 1. So please take a look first. All right, so let's go through the statements one by one. The first one, Coase theorem's conditions are ideally applicable to the case of traffic congestion externality on public roads. So this is actually false. Because we need two conditions of Coase theorem to hold, right? The zero negotiation cost and clearly defined property rights. So using the zero negotiation cost condition, as you can imagine, if the travelers or the drivers in the public road system would like to negotiate with each other, they need to come up from the car, and many drivers are standing on the public road to negotiate with each other. As you can imagine, it's quite clumsy and chaotic. And at the very least, time cost will be involved in the negotiation process. So this means that the condition about zero negotiation cost cannot be satisfied for statement 1. Okay, statement 2, travelers in a congested public road system inflict negative externality on each other. So this would be correct, because imagine there are 100 cars in front of you, then you need to need those cars to pass through the tunnel before you can go through it, right? And let's say there are a few more cars, okay, driving in front of you, then it takes more time for you to go through this public road system. And these additional cars are inflicting certain time cost to you without compensating you. So this fits into the meaning of negative externality. Okay, so statement 2 is correct. Okay, so that's all for question 1, and we'll move on to the next problem. Okay, so let's start with question 39 to find the socially efficient outcome. So we are going to calculate the total economic surplus of building a 10-story hall and a 20-story hall to see which would give a greater total economic surplus. Okay, so total economic surplus can be calculated as follows: the gain to students minus the damage to Stephen. So let's say the total economic surplus of building a 10-story hall will be 1 minus 0, which is 1, while the total economic surplus of building a 20-story hall will be 2 minus 5, which is negative 3. So this is how we can calculate the total economic surplus. And apparently, the total economic surplus of building a 10-story hall is larger. So it will be socially efficient to build a 10-story hall. Okay, so question 40. Negotiation costs are negligible, and we have the two situations where Stephen has a right or the university has a right. What would be the hall that would be built? Okay, so actually we have both condition of Coase theorem here: the negligible negotiation cost, and also who has the right. Right, in the first blank, Stephen has a right, while in the second blank, the university has a right. And in any case, we have both conditions of Coase theorem hold here. So this is why the efficient outcome of building a 10-story hall is guaranteed. But still, let's analyze what would happen for the negotiation process in these two cases. Okay, so let's go through here. So to move from building a 10-story hall to a 20-story hall, the gain to students would actually increase by 1, while the damage to Stephen would be increased by 5. Okay, so this is the starting point for our analysis. And let's start with the first scenario where Stephen has a right to have an unobstructed view. Then the analysis will start by building a 10-story hall. Okay, if the university and Stephen is trying to negotiate whether to build a 20-story hall instead, then Stephen has to be compensated at least $5 because this will be the additional damage to Stephen when the 20-story hall is built. While for the university, they are only willing to pay at most $1 for it because the gain to students only increased by $1. as you can see, they cannot reach an agreement to build a 20-story hall because the maximum amount afforded by the university is lower than the required amount by Stephen. Okay, so anyway, the market will stay at building a 20-story hall in this first case. But in the second case, where the university has a right to select whichever plan, then the analysis will start by building a 20-story hall. So they are trying to negotiate whether to build a 10-story hall instead. Then the university has to receive at least $1 because by building a 10-story hall instead, the gain to student will be reduced by 1. But for Stephen, he is willing to pay at most $5 because this would reduce the damage by 5, right? So as far as the amount of compensation is between $1 and $5, then the two parties can reach an agreement to build a 10-story hall instead. Okay? So as you can see here, with both conditions of Cole's theorem, the efficient outcome of building a 10-story hall can be guaranteed. And for question 41, everything is the same, just that we have $4.1 million of negotiation costs to hire lawyers. So what will happen in the two cases here? Okay. So in the first case where Stephen has a right, then the analysis will start by building a 10-story hall. And even without the existence of negotiation costs in question 40, they cannot reach an agreement to build a 20-story hall instead. And here, with the existence of negotiation costs, it is even harder to reach an agreement between the two parties. So this is why in case 1, where Stephen has the right, then the market will just stay at building a 10-story hall. But in the second case, where the university has the right to select whichever plan, the analysis starts by building a 20-story hall, right? So let's see. What will be the benefit and the cost of negotiation? The benefit of negotiation is to increase the total economic surplus by $4, while the cost of negotiation is the $4.1 to hire lawyers, right? As you can see, the cost of negotiation is greater than the benefit of negotiation, and this is why they cannot reach an agreement to build a 10-story hall, the efficient outcome, right? So as you can see, having negotiation costs, the efficient outcome cannot be attained. Okay, so that's all for this problem, and we'll move on to the next one. Please take a look first. Okay, so let me start with question 42 to select the production process used by firm X and Y. If pollution is unregulated, then both firms will choose a production process that incur the least cost, which is using process G. Okay, so the total sewage discharge for process G is 6 tons, and we have 2 firms here. So the total sewage discharge will simply be 6 plus 6, which is 12 tons. Okay, so for question 43, if the city council decide to cut the total sewage discharge by 2/3, and what would be the total cost of pollution control to society? So if each firm is required to cut sewage discharge by 2/3, which means that each of them can only emit 2 tons of pollution. And equivalency, which is using process C. So how can we calculate the total cost of pollution control? It is simply the additional cost to use the less polluted production process. Let's say from the perspective of firm X, originally it is using process G, incurring a cost of 120, but now it should use process C to incur a cost 1,670. So the additional cost would be 1,670 minus 120 as the cost of pollution control to firm X. On the same token, we do something similar for firm Y. Originally, it is using process G with a cost of 440, but now it is using process C. The cost is 3,510. So the additional cost required is 3,510 minus 440 as the cost of pollution control to firm Y. So the sum of these two differences would give us the answer 4,620 as the associated total cost of pollution control. Okay, so question 44, we are going to find the range of the tax T such that it can attain the target of reducing sewage discharge by 2/3. Okay, so let me take this opportunity to construct the marginal cost table here with you and to explain how it comes out. Okay, so let me shift my screen to Excel here. Okay, so for the table here is directly given. So what I'm trying to go for is how to obtain this marginal cost table. Okay, so for this number, it means that if firm X is going to reduce the first ton of pollution, what would be the additional cost or the marginal cost required? It would simply be 320 minus 120, because if firm X would like to reduce the first ton of emission, it will move from using process G to process F, and the additional cost required is 200. And by the way, for the marginal cost table here, I reverse the order, okay, from higher level of pollution to a lower level of pollution, simply because we'd like to see how firms is going to make decisions on whether to reduce the pollution amount. Okay, so if firm X is going to reduce the second ton of emission, it will move from using process F to process E, and the additional cost required is 550 minus 320. We also have the similar logic for other cells in this column and also for firm Y, and this is how we can construct the marginal cost table here. And we are now ready for our analysis. Okay, so it will be a cost and benefit analysis of the firm. The benefit side of reducing pollution is avoid paying the tax T that we are going to find, while the cost side of reducing pollution is to use a less polluted production process, okay, with a higher cost. So let's say the amount of tax is $800. Then firm X will reduce these 5 tons of emissions, while firm Y will reduce these first 2 tons of emission, because by reducing these tons of emissions, it need to pay the pointed numbers, okay, the marginal cost, but it could save the cost of paying the tax $800. So this is why the firms would reduce this much amount of pollution. As you can see, only 7 tons is reduced if the tax is 800, and it has not yet reached the target. And specifically, if it would like to reduce 2/3 of sewage discharge, which is reducing 8 tons of emission, then the tax has to be at least 820, such that 8 tons will be reduced in total. However, the target is to reduce sewage discharge by 8 tons, but not further. So this is why the tax cannot be too large, or else firms will reduce pollution more than the desired level. And specifically, the tax cannot be higher than 900, or else the 9th ton will be reduced. All right, so hope this explains question 44. And for question 45, we're going to find the total cost of pollution control and also the government tax revenue. So the total cost of pollution control, the idea is the same, which is the additional cost to use the less polluted production process. So by what we have just explained here, firm X will be using process B, while firm Y will be using process D. Okay. If firm X is using process B, it will move from this 120 to 2,430. So the difference between the two numbers would be the cost of pollution control to firm X. while for firm Y, it is using process D. The additional cost required would be 2,540 minus 440 as the cost of pollution control to firm Y. So again, the sum of these two differences will give us the answer to the first part here, the total cost of pollution control. And not surprisingly, the associated total cost of pollution control here is 4,410, which is lower than the number we have obtained in question 43, which aligns with the idea that firms with lower cost of abating emission would reduce pollution first. Okay, so finally, the second part of question 45, to find the government's daily revenue. So actually, we have found out the range of per unit tax T here in question 44. And after this range, we know that the total amount of sewage discharge is 4 tons. So if we multiply 4 to both sides of the inequality here, it is simply the range of the total tax revenue. And this is why I have the range here, and the minimum daily revenue is 3,280. Okay, so question 46 and 47, everything is the same, just that the city council used the permit to tackle with the problem of externality instead of the tax. What will be the range of the permit price P and also the total cost of pollution control as well as the daily government revenue? So actually, if we change everything about tax in question 44 and 45 to the permit price for permit, is automatically the explanation to question 46 and 47, because we need to recognize the equivalence of using tax and pollution permit to tackle with the problem of negative externality. So this is the key point that we need to recognize. And this is why, without any calculation, we can complete question 46 and 47 afterwards. Right? The range of the permit price P is between 820 and 900, and the same total cost of pollution control and daily government revenue. All right, that's all for the problem itself. And here I have some additional part for our discussion. So instead, if the government issues 4 pollution permits that are free to the firms instead of requiring a price, if negotiation cost is negligible, what would happen in the following cases where all pollution permits are granted to firm X, and the second situation where the permits are all granted to firm Y? So what will happen in these two cases? So let me shift my screen to Excel again to explain numbers in more detail. Okay, so if all pollution permits are granted to firm X, then the analysis would start as follows. Firm X using process E, okay, emitting 4 tons, and firm Y is using process A, emitting 0 tons. Okay, so they are trying to negotiate whether to trade for the pollution permit. So let's say if firm X is going to sell 1 pollution permit to firm Y, it needs to move from using process E to process D. The additional cost required is 480. While for firm Y, if it has 1 pollution permit, it could move from process A to process B, right? So it can emit 1 ton of pollution, and it would save the cost of 1,130. So as far as the permit price between the two firms is between 480 and 1,130, then they can reach an agreement to trade for the first pollution permit. Okay, then we'll demonstrate for one more unit. Let's say they are trying to negotiate whether to trade for the second pollution permit. Then firm X would need to move from using process D to process C. The additional cost required is 640, while for firm Y, it would move from using process B to process C, and it could save the cost of 1,020. So as far as the permit price is between 640 and 1,020, then they can reach an agreement to trade for the second pollution permit. Okay, so this logic also applies to the third pollution permit, but not the fourth pollution permit, because firm X has to receive at least $900, while firm Y is willing to pay at most $820 for trading the fourth pollution permit. So they cannot reach an agreement to trade for this unit. And ultimately, firm X will have 1 pollution permit remaining, and firm Y has 3 pollution permits. And this is why firm X will be using process B, while firm Y is using process D. Okay, so this is the first scenario. How about the second scenario where all pollution permits are granted firm Y? Then the story will start as follows. Firm X polluting 0 tone using process A, while firm Y polluting 4 tones using process E. Okay, they're trying to negotiate whether to trade for the first pollution permit. So firm Y need to receive at least 820, while firm X is willing to pay at most 900. So as far as the permit price is between these two numbers, then they can reach an agreement to trade for the first pollution permit, but not for the second pollution permit because firm Y has to receive at least 970, while firm X is willing to pay at most 760. So the negotiation would end here. Firm X will have one pollution permit and emit 1 ton of pollution, while firm Y would have 3 pollution permits to emit 3 tons. So again, the same result. Firm X will end up using process B, while firm Y will end up using process D. So the takeaway is that with the condition of Cole's theorem hold, right, zero negotiation costs and clearly defined property rights of who have the pollution permits, then efficiency can be attained, just that the distribution of the welfare would differ. Okay? We could also have any other case of distribution. Let's say the pollution permits are granted half to firm X and half to firm Y, 2-2, or 1-3 or 3-1, or whatever allocation. As far as the conditions of Cole's theorem hold, then the efficiency of society can be attained. All right, so that's all for this problem, and we'll move on to the next one. So actually, for this problem, it's quite similar to the one we have just discussed. The more intriguing thing is question 41. So please spend more time to think about question 41. Let me still briefly explain the first few parts of this problem. So question 36, to find the total amount of solid waste pollution. So in this case, if pollution is unregulated, then firms would choose the production process that would give the greatest profit, which is using process G for both firms. And total sewage discharge will be 6 plus 6, which is 12 tons. Okay, question 37. If we have a permit price 1155, what will be the production process chosen by the two firms? Okay, again, it will be the cost and benefit analysis of the firm. The benefit of reducing pollution is avoid paying the permit price 1155, while the cost of reducing pollution is a loss in profit, which can be calculated in this marginal cost table here. Okay. And as you can see, as far as the marginal cost is lower than the marginal benefit of 1155, then the firms will reduce that ton of pollution. So firm X and Y will reduce the yellow highlighted numbers. Okay. And finally, firm X will be using process D, and firm Y will be using process C. And for question 38, the government daily revenue. So after this permit price of 1155, they would reduce their pollution to only 5 tons. Okay, a permit price 1155 multiplied by the emission of 5 tons, then the government daily revenue is this number. And for question 39, if the government would like to cut the total solid waste pollution to 2/3, what will be the range of the permit price? And be aware, this time, the question is saying that it is cut to 2/3, not cut by 2/3. Is different, okay? It's different from the previous question. Be aware of this preposition. So if the government would like to cut to 2/3, which means that firms are allowed to emit in total 8 tons of pollution. Okay. And again, the permit price cannot be too high and it cannot be too low. Okay. And it has to be between 730 and 980. If it is too low, firm will not reduce as much pollution as desired, while if the permit price is too high, then firms should reduce pollution more than the desired level. Okay, question 40, to find the social efficient level of pollution. So it will be the cost and benefit of society as a whole this time. So the benefit of reducing pollution to society is avoid the environmental damage of 995, the number at the very beginning here. While the marginal cost of reducing pollution to society as a whole will be the reduction of profit of the firms, referring to the marginal cost table on the left-hand side here. Okay. As far as the avoidance of environmental damage 995 is greater than the numbers in this marginal cost table, then it will be social efficient to reduce that ton of pollution. And as you can see, the social efficient level of pollution should be 7 tons. And finally, for question 41, everything is the same, just that we have a negotiation cost of 100.5 to hire lawyers. Okay, what will be the amount of solid waste generated in this case? Again, it will be the cost and benefit analysis of society as a whole. The marginal social benefit side is again the avoidance of environmental damage 995, while the marginal social cost of reducing pollution composed of 2 parts: the loss in profit of the firm in the marginal cost table here, plus the negotiation cost of hiring lawyers, 100.5. So to calculate the marginal social cost component, we just add 100.5 to all the numbers in this marginal cost table, and we should be able to get the marginal social cost on the right-hand side here. And as far as the avoidance of environmental damage 995 is greater than the marginal social cost, that they can reach an agreement to reduce that ton of pollution. And as you can see, the total solid waste pollution generated will become 8 tons in question 41. All right, so that's all for this one, and we'll move on to the next problem. Please take a look first. All right, so let's start with the explanation. As you may aware, there are both external cost and external benefit for this question. So how can we deal with this problem? Yeah, so don't panic, and at least don't panic after listening to my explanations. So in any case, let's try to find out the social efficient quantity and market equilibrium quantity so that we can move on to analyze the total economic welfare and also to find out the welfare loss and something like that. Okay, so for the market equilibrium quantity, we impose the market equilibrium condition, MPB equals to MPC. Okay, so we just put the 2 private curves here, and we should be able to find out the market equilibrium quantity is 195. How about the social efficient quantity? we need to find the intersection between MSB and MSC. So we need to derive that on our own right now. So marginal social benefit would be the marginal private benefit here plus the marginal external benefit, and which is the thing here. Well, for the marginal social cost, it will be the marginal private cost of this expression plus the marginal external cost here. And I put down here as well. And we have successfully derived the two social curves. Putting these two expressions in GeoGebra and to find the intersection, we have the social efficient quantity, which is 120. Okay, and actually, as you can see, the market quantity is greater than the social efficient quantity, which means that there's overproduction in the market. So to find the total economic welfare, you should expect that we have a dead weight loss on the right-hand side, right? So it should be somewhere like here, right? The blue triangle minus the red triangle. And what would be the specific curves that we need to consider? Because when we're talking about total economic welfare or dead weight loss, it is about social things. So this is why we use the two social curves to find out the area of total economic surplus or dead weight loss. Okay, so the dead weight loss here, the red triangle, is the area constrained by the marginal social benefit, marginal social cost until the market equilibrium level. So let me repeat. The dead weight loss is the area constrained by the marginal social benefit, marginal social cost until the market equilibrium level. So this red triangle will be the dead weight loss at the market equilibrium. So to find the total economic surplus, is simply the maximized level minus this dead weight loss. Okay, so this is how we can complete the first two questions. And for question 5, in order to induce the efficiency, what would be the policy to be executed and by what amount? So this time, because we have overproduction, right? So this is why we like to use Pigouvian tax to disincentivize the production and consumption of the good. But by what amount of per unit tax imposed? So let's think about that. If there's only external cost in society, then the right amount of per unit tax to be imposed would be the marginal external cost at the efficient output level. Here, the efficient output level is 120. On the other hand, if there's only external benefit in society, then the right amount of per unit subsidy imposed is the marginal external benefit at the efficient output level, 120. Now, we have both external cost and external benefit. So the right amount of Pigouvian tax is simply the net amount of these two things. Okay, so how can we find the marginal external cost at the quantity of 120? Nothing special. We just need to plug in 120 back into this expression. Then we have the marginal external cost. While for marginal external benefit is constant at 100. So this is why we have the required amount of tax to be the expression, which is $300. And finally, question 26, we have a license plate instead of the policy in question 25. What would be the permit price and also the revenue of the government? Again, we need to recognize the equivalence between using tax and the tradable license or the pollution permit to tackle the problem of overproduction or negative externality. Okay, so this is why we have the same license plate price as the per unit tax, 300. Okay, how can we calculate the total revenue from the license plates? Because each license plate is at the price of 300, and at the efficient quantity, it is 120. So this is why the total revenue is 300 multiplied by 120 as the total revenue, 36,000. Okay, so that's all for this problem. And before moving to the next problem, the last problem in this tutorial, I would like to take a break from my lecturing. Okay, so I'll give you some time to complete the attendance exercise first. So 5 minutes as usual, and I'll close the quiz at around 9:32. And afterwards, we will continue our discussion on the last problem. So 2 minutes left for the attendance exercise. And in case you have already completed the exercise, then you can also spend some time to skim through the problem that I will discuss very soon. All right, so time is up and I'll close the quiz soon. So in the meantime, please take a look at this problem before I go into the explanation. All right, so let's start. So in any case, let's find out the curves, the private and the social curves first. For those that have been mentioned directly, I have already put down in the following slides. But for those that have not yet been mentioned, let's say for the marginal external benefit, it's simply there's no external benefit to Jones because Jones doesn't even enjoy the music. So this is why for those that have not yet been mentioned, I just take it as 0. And this is why we can also obtain the two social curves here. Okay. So for question 27, if negotiation between Smith and Jones is impossible, what will be the economic surplus accrued to Smith and Jones when Smith has a right? Okay. If Smith has the right to listen to music and negotiation is impossible, then Smith would just listen to music until the point where the marginal benefit equals to 0. So this is why we are finding the x-intercept of the green marginal benefit curve. Okay, point F will be giving us such information. The market equilibrium quantity is 14 hours of loud music. So what will be the economic surplus accrued to Smith? It will simply be the area under the marginal benefit curve until the quantity of 14. So this purple triangle is the economic surplus accrued to Smith. Okay, the area is 49. Well, for the economic surplus accrued to Jones, it would be the area under the marginal external cost curve until the quantity of 14. This orange triangle would be the total external cost to Jones from these 14 hours of loud music. And be aware, total economic surplus is total benefit minus total cost, right? Simply, there's no benefit to Jones in listening to the loud music. So this is why the negative of the total external cost is already the total economic surplus to Jones in this case. Okay, so the area is 88.2. All right, so this is for question 27. While for 28 and 29, we have the scenario where negotiation costs are negligible and Smith has the right to listen to the loud music. So again, because we have both conditions of Cole's theorem, the 0 negotiation cost and also who has the right. So this is why we have the efficient outcome to be guaranteed. Okay? We will use the intersection between the two social curves to find out the quantity of loud music listened. So we just equate the two social curves, and we will have the efficient quantity, which is 5. Okay. If you're referring to the numbers, you can take a look at this slide, okay? The slide of question 32, and you will be able to find out that the quantity as suggested by point B would be the efficient quantity. Okay, I cannot put the graph, the numbers here because there's quite a limited space. So if Smith has a right to listen to the loud music, then Jones need to pay Smith to reduce the loud music listened, and meaning that the negotiation will start from Q equals to 14 to Q equals to 5. Right, so what is the economic surplus accrued to Smith? It would be composed of two parts: the benefit from listening to the loud music and also the compensation. Since Smith is the one who received the compensation, so this is why we put a plus sign to indicate it's a gain to Smith. And the smaller the compensation, the smaller the total economic surplus. So this is why the minimum compensation to find the minimum economic surplus and maximum compensation to find the maximum economic surplus to Smith. All right, so what would be the total benefit of listening to 5 hours of loud music? It would be area under the marginal benefit curve until the quantity of 5. So this purple trapezium is the total benefit from listening to first 5 hours of loud music. So again, if you're referring to the numbers, you can go 2 slides forwards to take a look at the numbers here. Okay, I'm just going to explain the location of the areas first. Well, the minimum compensation that Smith would accept, it is this blue triangle. Why? Because this blue triangle is the benefit that Smith can enjoy from Q equals to 5 to Q equals to 14. If the compensation is even smaller than this amount, then Smith would just reject the offer from Jones and to continue listening 14 hours of loud music. So this is why the compensation has to be at least this blue triangle. Okay, so what about the maximum compensation? It will be constrained by this green trapezium. And this green trapezium is actually the total external cost suffered by Jones from Q equals to 5 to Q equals to 14. If the compensation is even greater than this green trapezium, then Jones would just choose to suffer from the loud music and not to negotiate with Smith. So this is why the maximum compensation is constrained by this green trapezium. Okay, so putting all the numbers here, then we can find the upper bound and the lower bound of the economic surplus accrued to Smith. How about the economic surplus accrued to Jones? Again, it's composed of two parts: the total external cost part and also the compensation. Since Jones is the one who paid the compensation, so we put a negative sign to indicate that it's a loss to Jones. And the larger compensation, the smaller the economic surplus. So maximum compensation to find the lower bound and the minimum compensation to find the upper bound of the economic surplus accrued to Jones. Okay, for the compensation part, I've already explained in the above, so I'm not going into the details. And the final thing to go through is the total external cost from listening to 5 hours of loud music, which is area under the marginal external cost curve until quantity of 5. So this orange triangle would be the total external cost from listening to 5 hours of loud music. Okay, so this is the scenario where Smith has the right. And how about question 30 and 31? Negotiation cost is still negligible, and Jones has the right for the quiet environment in this case. So again, we have both conditions of Cole's theorem. The efficient outcome of listening 5 hours of loud music can be guaranteed using the social efficient condition MSB equals to MSC. But for this time, negotiation will start from Q equals to 0 to Q equals to 5. And Smith is the one who paid Jones to receive the acknowledgement from Jones to listen to the loud music. Right, so what will be the economic surplus accrued to Smith? Composed of two parts: the benefit of listening to loud music and also compensation. This time, Smith is the one who paid compensation, so a negative sign to indicate a loss. And the larger compensation, the smaller the economic surplus. So the maximum compensation to find the lower bound and minimum compensation to find the upper bound of the economic surplus accrued to Smith. Okay, so for the total benefit part, okay, the same purple trapezium that I've just explained in the previous slide. While for the maximum compensation, it is constrained by this purple trapezium as well, because this purple trapezium can also be interpreted as the total benefit of listening to 5 hours of loud music. If the compensation is even greater than this purple trapezium, then Smith would just choose not to listen to any music. Right, so this means the compensation is at most this purple trapezium. While the minimum compensation will be constrained by this orange triangle, because this is the total external cost suffered by Jones for the first 5 hours of loud music. If the compensation is more than this amount, then Jones will just reject the offer and not to allow Smith to listen to loud music. Okay, and yeah, so that's basically about the economic surplus accrued to Smith. But finally, for Jones, the total external cost part, the orange triangle. And this time, Jones is the one who received the payment or the compensation. So we put a plus sign to indicate that it's a gain to Jones. And the smaller the compensation, the smaller the economic surplus, and vice versa. So minimum compensation to find the lower bound, and maximum compensation to find the upper bound for the economic surplus accrued to Jones. So plugging all the numbers here, then we have the inputs. Question 32 to conclude this problem, right? So we are going to determine what will matter in this case. So because we have both conditions of Cole's theorem, well-defined property rights and also zero negotiation costs, then we know that the efficiency must be attained. And as you can see, in question 28 and 29 versus in question 30 and 31, we have the same efficient outcome of listening to 5 hours of loud music. Okay, so this means that the property right assignment does not matter for the eventual total economic welfare or the efficiency of society. What matters is the eventual welfare distribution among the individuals who get more of the economic surplus among Smith and Jones would matter in this case. Okay, so that's pretty much about the content of the tutorial today. And yeah, so thank you very much for bearing me until 9:45, right? Override quite a lot for this topic. So if you have any question, you can also stay behind and ask them. And yeah, if not, then take a good rest and see you all on Wednesday. Goodbye.